Devices used for measuring pressure include a barometer, which is typically used to measure atmospheric or outside air pressure. Initially, it was Torricelli who did this, or who was recorded as doing this measurement, and he had an open bowl of mercury. Now it's in a closed tube to prevent mercury vapor, because we know that's toxic. So it consists of a tube of mercury being placed in enough mercury that it can flow upwards just based on the natural pressure that's occurring at sea level. Sometimes in chemistry problems they'll say that the gas reaction took place at sea level, and they expect you to know that that's 760 millimeters of mercury, or 1 atm, or 14.7 psi. All of the equivalents for gases are done at sea level. A manometer, so sometimes you'll hear or see a manometer in your book, and these are used to measure the pressure of a contained gas. So it's a gas in a closed container. That's the difference between a barometer, which measures outside air pressure, and a manometer, which is measuring a contained gas. The ideal gas law gives information about a gas at a single time point, meaning you will only have initial values when you write out all of the volumes and pressures and everything that's given in the problem. The ideal gas law is PV equals nRT, or Pervnert. P equals pressure, V equals volume. N is the number of moles of gas, and this could be grams. So often they'll say so many grams of a certain gas, and you should right away think that that is moles, because you can do a quick conversion and get moles. R is 0.08206. Sometimes it's written as 0.0821. It's just rounded. Liters ATM over moles Kelvin. T is temperature, and temperature for all gas laws, including the ideal gas law, must be in Kelvin. Because R is in liters, pressure must be in liters for the ideal gas law, and because because volume is in liters, your volume must be in liters and your pressure must be in ATM, or atmospheres, for the ideal gas law. So liters and ATM, which doesn't matter with other gas laws, does matter with the ideal. And then temperature for any gas law has to be in Kelvin. So you just add 273 to Celsius, which is shown right here. So temperature Celsius plus 273 is going to give you your temperature in Kelvin. So we could also rewrite this ideal gas law as PV over RT equals, and it's a little m, which means mass, over a big M, which means molar mass. So N has been replaced with mass over molar mass, and M is just the mass of grams of gas that's given, and M is your molar mass of the gas, which you can get from the periodic table. So this actually allows you to solve for the molar mass of a gas if you're given the mass of a gas. So yes, this will help give you the molar mass of a gas, or the moles if they've just given you a mass and they've given you the molar mass. So remember, big M stands for molar mass, little m stands for mass, and this is only used when they are asking for molar mass of a gas and they haven't given you moles, or if you are given mass and you're given the type of gas, then you can get the moles of a gas. So here's a simple ideal gas law problem. They say 25 grams of oxygen gas is placed in a 2-liter container at 292 Kelvin, and they want to know what is the pressure in the container. So the first thing you want to do is write out what you're given. You don't know moles, but you do know the identity of the gas, and you know the amount. So you can do a quick conversion using molar mass, and 25 grams is what you were given, divided by 32 grams of O2 is the molar mass, will give you 7.781 moles of O2. So N1 is 0.781 moles. Your V1 was given, it's 2 liters. Your T1 is 292 K. Your P1 is what you're trying to solve for. PV equals nRT. R is always 0.0821. I rounded. It could be 0.08206, same thing. Liters, ATM, moles, Kelvin. So if we rearrange to solve for pressure, then we get pressure equals nRT divided by V and you plug in your moles, 0.781, you plug in your R, 0.0821, you plug in your T, 292 K, and you divide by V, which is 2 liters, and you'll get a pressure to 1 sig fig of 9 atm. STP is standard temperature and pressure. So temperature, the standard is 273 or 0 degrees Celsius. Standard pressure is 1 atm. And they will ask what is the volume of 1 mole of gas at standard temperature and pressure. And the answer is 22.4 liters. That can save you a lot of time because if they want to know the volume of a gas and they say it's at STP, you can quickly remember that 1 mole of any gas is 22.4 liters at STP.